right, welcome back. Last week we talked about simplifying. So this was, just to refresh your memory, this was, say, taking things like 2 times the square root of 20x squared plus 5 square root of 125x squared. Okay, and simplifying this, seeing if there's things that we can change to add these together. So I know 20 is 4 times 5. And the square root of 4 is 2, so I can pull a 2 out, and I'm left with the square root of 5 on the inside. The square root of x squared is x, so over here I've got 4x times the square root of 5. On this one, 125, this is 25 times 5. So square root of 25 is 5, so I've got 5 times 5, and I'm left with the square root of 5. Square root of x squared again is x, so I've got plus 25x times the square root of 5. All right, my radicals are the same, which means I can add these together. So what I actually have is 29x square root of 5. All right, that's one example of simplifying. Another one was if I have 32a to the 4th over b squared. Okay, this is the same as saying the square root of 32a to the 4th over the square root of b squared, which is also the same as saying 32a to the 4th to the 1/2. The square root of b squared is obviously just b. 32 breaks down to 16 and 2. Square root of 16 is 4. A to the 4th to the 1/2 is a squared, and I'm left with this square root of 2 all over b. So this is the simplified form of that. All right, so we're going to kind of use simplifying. What we're going to do today is called rationalizing. So rationalizing is when you have a square root on the bottom, and even when you simplify it, it doesn't go away. So we don't want those square roots on the bottom, so we're going to find a way to move them to the top. All right, so we're going to do lots of examples to show you how this works. All right, so if I'm looking at this first one, I'm going to see if there's anything I can simplify in that. Well, so I have square root of 14, which is even, but there isn't anything that goes in there nicely to be able to pull anything out. So the way I'm going to get rid of that or move it to the top is to multiply times the square root of 14 over the square root of 14, which is just 1. So I'm not actually changing my equation at all, but this will allow me to bring that square root to the top. All right, so I've got 8 times the square root of 7 times the square root of 14. And on the bottom, square root of 14 times the square root of 14 just leaves me with 14. All right, I can simplify this further. Remember, one of the properties of square roots is I can separate them, and I can also bring them back together. So if I'm looking at square root of 14, this is also equal to 7 times 2. Okay, so I have the square root of 7 times 2. See how I can bring everything separated out and bring it back together? Which means that what I actually have is 8 times 7 to the square root of 2, because I've got 2 7s, so I can pull 1 out over 14. All right, so I'm looking at this, and I can simplify without having to multiply 8 times 7 and then divide by 14. I can simplify this. I know that 7 goes into 14 twice. I know that 2 goes into 8 once, so I can do some canceling there. So I actually have 4 square root of 2, which is actually the simplified version of that problem. All right, number 2. So same thing again. I looked at this one. There wasn't anything I could simplify, but this one there actually is. The square root of 16 is obviously 4. So we actually have on top is 3 times 4, or 12. And on the bottom, I have a square root of 12, which I could simplify. This is the same as 4 times 3, which I can bring that square root of 4. So I've got 2 times the square root of 3 on the bottom. So I've got 12 over 2 times the square root of 3. Now to get rid of the square root of 3, so I've got 12 over 2 times the square root of 3. I'm going to multiply Square root of 3 over the square root of 3. And we're just multiplying fractions, top times top, bottom times bottom. So 12 times the square root of 3. 2 times, I have 2 square root of 3, so this cancels out to become just a 3. So I've got 2 times 3, which is 6. Can cancel that. That should be square root of 3, not 13. So I actually have 2 times the square root of 3. Now, there's another way I can simplify this without pulling that 4 out first. I'm going to take the square root of 16 as 4. So I'm still left with 12 on the top. So this is going to be my OR. Okay, so I've got 12 on the top over the square root of 12. All right, I can multiply just right away. I can say square root of 12 over square root of 12. So I'm left with 12 times the square root of 12 over 12. Those 12's cancel out. Square root of 12 we said simplified down to 2 times the square root of 3. Okay, either way, it gets you the same answer. All right, so what happens when I have other numbers in here? It's not just a simple something over something else. All right, square root of 19. 19 is prime, so there's nothing I'm going to be able to pull out of there. So I'm still going to do the same process. Square root of 19 over square root of 19. Remember, I'm just multiplying everything by 1. All right, so I need to FOIL this square root of 19 in there. So I have 9 times the square root of 19 minus 5 times the square root of 7 times the square root of 19. All right, on the bottom, I've got 10 times 19, so I've got 190 down there. All right, so to simplify this, I'm going to kind of combine everything here. So I've got 9 times the square root of 19 minus 5. I can multiply those two together, and I get 133. And on the bottom, I have 190. There's nothing that goes into both 9 and 5 evenly, so there's nothing I can pull out of the top. So this is my simplified answer. Does not look any simpler than what we started with, but this is my rational answer. All right, same thing for this one. So I've got square root of 19 multiplied by top and bottom. So I have 2 times 19, which is the square root of 38, minus, I've got 19 times 6, so the square root of 114, all over 19 on the bottom. And that's my rational answer. All right, so the conjugate, multiplying by the conjugate. So the conjugate just means that I have something like 5 plus the square root of 3 on the bottom. So let's say I've got 3 over there. Now, if you remember when we were doing way back when we were doing factoring and quadratics. So if we had something like x plus 4 squared, this gives us a middle term. When we multiply it out, oops, that should be a 4. Okay, we did the boxes. We've got 4x, we've got 4x, and we've got 16. Look a little nicer. Okay, this gave us a middle term. So we have x squared plus 8x plus 16. So we can't just multiply by the square root of 3 here because we're still going to end up, this will fall away, but we'll still end up with a square root of 3 there. So what we're going to do is we're going to multiply by, we're going to change the sign in between. So that's called the conjugate. So in this case, the conjugate is 5 minus the square root of 3. So if we had x plus 4 times x minus 4, this is going to make that middle term go away. So we end up with a minus 16, or x squared minus 4 squared. All right, so it's the same principle for this. So this is a plus. If I multiply with a minus in between, that middle term is going to fall away. We'll do some examples of this. All right, so to rationalize this one, I am going to take it times 10 minus 9 square root of 7. All right, and what this is going to do is it's going to make the square root of 7 fall away. So again, multiply across the top. So I've got 100 minus 90 times the square root of 7. So multiply both those terms by 10. And on the bottom, we can do the boxes to show you how this works. Okay, we've got 100, we've got 90 times the square root of 7, we've got minus 90 square root of 7, and we've got a minus 81 times 7. Which ends up being 567 when you multiply it out. All right, so you notice these middle terms go away. So on the bottom, I'm left with 100 minus 567. All right, so I'm going to simplify this a little bit. So I've got 100 minus 90 times the square root of 7. And on the bottom, I have minus 467. I don't like that minus on the bottom. So I'm going to get rid of that. This is just like pulling a negative 1 out. Remember, I have to pull a negative 1 out of everything. So I'm just changing the signs for everything. So what I actually have is this becomes positive, negative, positive. Okay, so this ends up being 90 square root of 7 minus 100. Just so I don't have that negative hanging out front. Over 467. This is the rationalized answer. All right, let's try another one. All right, so this time I've got a negative out front. I'm going to leave it there. So we're still going to multiply by negative 1, but I'm going to add plus 8 square root of 10 over negative 1 plus 8 square root of 10. All right, again, I'm going to multiply both those terms by 3. So I've got a negative 3 plus 24 square root of 10. And on the bottom, so if you need to do the boxes to figure this out, do the boxes. So I've got a negative 1 and a minus 8 square root of 10 and a negative 1 and a plus 8 square root of 10. All right, so negative 1 times negative 1 is 1. This becomes a positive 8 square root of 10. This becomes a negative 8 square root of 10, and this becomes a negative 64 times 10, or a negative 640. All right, so on the bottom, these cancel out, and I am left with a 1 minus 640, or negative 639. Again, I don't like that negative on the bottom, so I'm just going to change the signs of everything. This is like pulling a negative 1 out. So this actually becomes 3 minus 24 square root of 10 over 634. 39, sorry. All right, that's my rationalized answer. They don't always look pretty, but there's no square roots in the bottom. All right, so we're getting a little bit more complicated here. So we're doing lots and lots of examples today. All right, so same process for minus 2 times the square root of 6 over 4 minus 2 times the square root of 6. Okay, now I've got 2 terms of 2 to multiply by. So if you can see to do FOIL, go ahead and do FOIL. Otherwise, boxes. So we've got 9 and 9 square root of 5. And we've got 4 and minus 2 square root of 6. All right, this one's going to get really messy. All right, so 9 times 4, 36. We got 36 square root of 5. We've got negative 18 square root of 6. And we've got negative 18 square root of 5. All right, this is just the top part of my answer. I'll write it in a different color here. All right, so nothing in here can be added together or simplified, or nothing cancels out. So what I have is 36 plus 36 square root of 5 minus 18 square root of 6 and minus 18 square root of 5. All right, that is the top. All right, now we need to do boxes again for the bottom, or you know that this these middle terms are going to fall out. So what I'm left with is 16 minus 4